All right, so we're in section 8.5. So we're going to talk about Cramer's Rule and area using matrices. So we've gone through several different ways of using matrices to solve systems of equations so far. We've talked about using row operations. We've talked about using inverse matrices to solve systems. Well, Cramer's Rule is just another tool that we can use to solve systems of equations. So just to set this up, if we have some system of two equations, and I'm going to say a1x plus b1y equals c1. So a, b, and c are just some numbers. This is our system of equations. And we have a2x plus b2y equals c2. So we have this system of equations. If we go through the process of solving this system of equations with row operations, and where everything is a variable, we don't have any numbers in here. If we go through that process, and I'm not going to go through it, I'm just going to tell you what we end up with. It turns out that x equals c1 times b2 minus c2 times b1 divided by a1 b2 minus a2 b1. If I go through that process, and it turns out that y, I get an expression kind of similar, is a1 c2 minus a2 c1 divided by a1 b2 minus a2 b1. So we go through this process and we find out that if we have a system of equations like this, that we can always figure out our solution this way. Well, what Cramer's Rule does is that we recognize, or a mathematician at one point recognized, that each of these is a determinant. This is a determinant of the matrix C1, B1, C2, B2, divided by the determinant A1, B1, A2, B2. And this, it has to do with two determinants also. This is A1, C1, A2, C2, divided by this same determinant, A1, B1, A2, B2. Well, if I write this as a matrix equation, my matrix equation is A1, B1, A2, B2 times x and y equals C1, C2. Well, this is just the determinant of this matrix. So my denominator is just the determinant of this matrix. I'll just write that as D. So I just have the determinant of this matrix in the denominator. And the numerator is the determinant of the matrix, this matrix, but here I replace the first column by these two numbers. I'm just replacing the first column by these two numbers. We call that D sub x. So I'm replacing the first column of this matrix by these two numbers. And this determinant is this matrix with the second column replaced by these two numbers. We call that D sub y. So to solve our system of equations, I can take this matrix, find the determinant, that's the denominator, and I can take this matrix, replace the first column by my column of constants, C1, C2, find the determinant of that matrix, put that up here, and this will give me X. And I can take this matrix and replace the second column by the column of constants, find the determinant of that, and that's going to give me Y. So this gives us another way to solve this systems of equations, just having to calculate determinants. And determinants generally, well, a 2 by 2 determinant is very easy to calculate. 3 by 3 determinants our calculator will calculate. But this gives us a way to not have to go through row operations or not have to go through inverses. So our denominator is just the determinant of our coefficient matrix. And the numerator is the determinant of the matrix where we replace the first column by the constants for the X and the second column by the constants for the Y. So let's look at an example of using Cramer's rule with a 2 by 2 system, and then we'll do a 3 by 3 system. So any questions on our setup before we move on? All right. So here's our system of equations. We have 2x plus 3y equals 4, and 6x minus 5y equals 1. And we want to solve this. So first I'm going to write it as a matrix equation. 2, 3, 6, negative 5 times xy equals 4, 1. So there's my matrix equation. So I need three things. I need the determinant of the matrix. I need the determinant of the matrix where I replace the first column with this column of constants, and the determinant of the matrix I get when I replace the second column with the column of constants. So the determinant of my matrix is just the determinant of this matrix. Two times negative 5 is negative 10, minus 18 is negative 28. D sub x, I'm going to replace the first column with the column of constants. That's going to be the determinant of the matrix 4, 1, 3, negative 5. 4 times negative 5 is negative 20, minus 3 is negative 23. D sub y, I'm going to take the determinant, replace the second column with the column of constants. 2 times 1 is 2, minus 6 times 4 is 24, and I get minus 22. So x is d sub x over d, which is 23/28. And y is d sub y over d, which is 22/28, which I can reduce to 11/14. And there's my solution. Calculated 3 determinants, divided twice, and I'm set.
So the negatives just like go away.
Well, I'm dividing a negative by a negative, so we get a positive. Right, 20. All of these were negative, so we end up with a positive answer. So this is way easier. Cramer's rule is way easier generally than using row operations, unless the row operation is really easy to do. Way easier than using row operations. Way easier than using an inverse matrix. So Cramer's rule can save us a lot of work. Calculating the determinants, pretty easy, especially with 2 by 2. Calculating the determinants pretty easy. When will we run into trouble with Cramer's rule? Anybody have an idea? Well, to get our answer, we're dividing here. Yeah, what do you think, Dan? If you have a bigger system, but if you have a bigger system, if we did a 3 by 3 system, we're going to use our calculator to find our determinant. And it takes time to put in the calculator, but it's not a difficult thing. But we're dividing here. We're dividing by the determinant. So what's going to give us a problem if we're dividing by the determinant? If the determinant was, what can I divide by? 0. If the determinant is 0, Cramer's rule won't work, and we have to use a different method. And if we also think back, if the determinant is 0, our matrix doesn't have an inverse, so we can't use inverse matrices to solve. So then we're back to doing row operations. So if our determinant is 0, we have to use another method to find our solution. But to use Cramer's method, we find the determinant of our coefficient matrix, the determinant with the first column replaced by the constants, the determinant of the matrix with the second column replaced by the coefficients, and then divide. The questions on that example? All right, let's look at, I just want to go through the process of doing this with a 3 by 3 matrix. And then we'll talk about an application to area with determinants. So for a 3 by 3, 4 by 4, anything bigger, the method is exactly the same. So I'm going to have my system 3x three x minus 2y plus 4z equals 0. Two x minus 8y equals 2. 4x minus 3y minus 5z equals 1. So I'll write this as a matrix equation. And because I have no z here, I'm going to put a 0. So this is my matrix equation. So the process of using Cramer's rule with the 3 by 3 system is exactly the same. I need to find the determinant of the matrix, and then to find x, I'm going to replace the first column with the coefficients. To find y, I'm going to replace the second column with the coefficients, find the determinant. And for z, I'm going to replace the third column with the coefficients and find the determinant. So I end up having to find 4 determinants here. So the determinant of our coefficient matrix. So with a 3 by 3, anything bigger than a 2 by 2, we're going to plug this into our calculator. So our calculator will find the determinant of our 3 by 3 matrix. If I plug this into my calculator, I'll put this 3 by 3 matrix into my calculator, use the determinant button. It would tell me that this determinant equals 204. D sub x, I'm going to replace the first column of this matrix with the constants. So I'm going to find the determinant of 0, 2, 1. -2, -8, 3 is my next column for 0, 5. And I would put that in my calculator. Find the determinant of that matrix. When I plug that in my calculator, it comes out to be -12. d sub y. I'm going to replace the second column with the coefficient with the constants. So I get 3, 2, 4, 0, 2, 1, 4, 0, 5. Calculator will find the determinant of a 3 by 3 matrix. When I plug that in my calculator, I get negative 54. And then I have a third variable, I have z. So I'm going to replace the third column of this matrix with the constants. And when I plug that in my calculator, calculate that determinant, and I get minus 18. And now I just have to find my fractions. So x is d sub x over d, which is negative 12 over 204. And I can reduce that. If I reduce that, that reduces to negative 117. Y is just d sub y over our determinant. D sub y is negative 54 over 204. And that comes out to be, when I reduce that, I get negative 9/34. D is d sub z over z. And I get minus 18 over 204, and I can reduce that to minus 3 over 24. And there are my solutions to that 3. Can I reduce it again? Sorry, this should be a 34. Thank you. If it was 24, we could reduce. And we're set. You have to calculate 4 determinants. Not difficult, kind of repetitive, kind of tedious. The nice thing about Cramer's rule is it's easy to program a computer to use Cramer's rule. So if your determinant isn't 0, a computer will do Cramer's rule fairly easily. So it is kind of mechanical, but that's one of the advantages of Cramer's rule, is that you can do it as a mechanical process. So questions on the process of Cramer's rule? All right. Last thing we're going to talk about today is using determinants to find the area of a triangle. All right, so if we have a triangle with vertices, we have three vertices, x1, y1, x2, y2, and x3, y3. The area of this triangle the absolute value of 1/2 times the determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. And I put the absolute value here is if we get a negative answer, our area always has to be positive. So to find the area of this triangle, I can find this determinant. So I have a 3 by 3 determinant. I can plug it into my calculator, divide that by 2, make sure my answer is positive, and I have the area of the triangle. No, this is for absolute value. So this is our determinant, and these bars are for our absolute value. So the area has to be positive. That's what that outside absolute value is telling us. So our area is always positive. So this has to do with if you go further in math, this has to do with when we talk about vectors. This determinant is what we call the cross product. It's a way to multiply matrices. And when in my Calculus 3 class, we do this determinant for cross products and matrices pretty much every day during this semester. This is something that we use repeatedly. Is this cross product when we talked about sides of triangles and vectors. So it's something that comes up a lot beyond what we're doing here. But let's look at an example of finding the area of a triangle. So we have a triangle with vertices 1, -1, 2, 3, and 5, -3. And we want to figure out the area. Now before I do this problem, I want to just make a quick sketch here. So if this is 1, over 1, -1, over 2, up 3, I'm just making a rough sketch, and over 5, and down -3. So here's a rough sketch of this triangle. If our problem asks us to find the area of this triangle and we didn't know this rule, that would be a really hard problem to do. We would have to find the length of one side. We would have to find the distance from one side to the other, the height. It would take a lot of work. Using this, very easy. So my area is going to be 1/2. And we're just going to make sure the answer is positive at the end. I'm going to make this determinant 1, -1, 1, 2, 3, 1, 5, -3, 1. Plug this determinant in my calculator. It's a 3 by 3 determinant. We can use our calculator to find that. And it turns out, and we make sure our answer is positive, we plug that into our calculator. It comes out to be 9. So this area, the area of this triangle would be 9 square units. And otherwise, finding the area of this triangle without using this method, the area is 9. So the determinant would be 18, and we should put the absolute value just to make sure we're saying that the area has to be positive. So that's all we have to do to find the area if we know the vertices of a triangle, is calculate that determinant. Questions on that? Okay. On Wednesday, we'll talk about how to figure out if we have lines to decide if 2 points in space lie, if 3 points in space lie on a line. All right, our homework. This should be 14, this could be 14 through 28. All right, there you go.